Hey guys, Stuart again. Today we're going to be having a look at some switches. I definitely don't have a problem with switches because these are all mine. So, what is a switch? Well, a switch is an electromechanical device which is used to control current flow. So, it's basically the simplest sensor that we can have, and when it's on, current can flow, and when it's off, current cannot flow. So, it could be a button on a keyboard, it could be a toggle like a light switch, and we use this to control power and stuff. So what do we do with switches, or what types of switches are there at least? So to start off with, we've got this one. This is a toggle switch. Focus on the switch. Okay, so a toggle switch has got a toggle and you turn it up and down. This is old school. This was, I think, from my grandfather, who was an electrician. And the cool thing is that you can see the contacts when you take the cover off. And when you push the toggle on the one side, boom, the contact closes and it can conduct electricity. If you flip it back, boom, the contact opens. And it's shiny and beautiful and old school. Right, so that is a toggle switch. Then we have, what's next? Let's look at the slide switch. The slide switch opens and closes contacts with a slide. So you slide it forwards and backwards, up and down. So that's on, that's off, depending on which way around it is, I guess. So there you can see basically what the switch is doing is this and this point will be connected when the switch is on this side, and when you push it to that side, then this and that contact will be connected and current can flow between them. This is exactly the same as the one that I just showed you. It's just slightly different configuration, slightly different size, and it's got two contacts on each side. So this is a double pole, double throw slide switch. Right. Then, so far we've looked at a toggle switch, we've looked at a slide switch. The next one, very similar to those two, it's a rocker switch. And basically this one has only got two contacts. If you're pushing it this way, it's off. If you push it that way, it's on. So it conducts. There's only two pins. It can conduct and it can't conduct. Okay, you can see it rocking up and down. So this is a latching switch, just like the other ones. Once it's pushed into that direction, it stays in that direction. It stays contacting. It's been pushed over. This is also another rocker switch. Focus, please focus. Okay, and so basically it's just a bit smaller than the one I just showed you. From there, we move over to what we call momentary switches. Switches that are only on for as long as they're pressed. So this is a push button switch. This one is the most satisfying switch I own because when you press it, it just makes you feel good about yourself. It's just got such a nice like when you press it, it's pressed, and when you let it go, it's unpressed. If somebody wants to push my buttons all day, if it's this button, I'll be happy with that. Right, this is exactly the same. It's just a little push button, but this one doesn't have a nice click like that one does. So this is on, off, on, off, and this is really, it's quite similar to the keys that we use on keyboards. Which moves us on to this switch. Now, this is the kind of switch that sits below your keyboard. It's what they call a tactile switch. And it's quite a nice name because it is quite a tactile feeling when you press it. It also makes a nice click. You can hear the click, you can feel the click, and that's why it is called a tactile switch. And it's momentary, so when it's pressed, it's on. When it's not pressed, it's off. This is the kind of switch that sits underneath all of your keyboards on your computers and your mouse. If you open up a mouse, you'll be able to see it's got little tactile switches like this. And there's different sizes and different types. This one is exactly the same. It's just got a red button and it's got longer legs or leads. This one's just exactly the same. It's just got a much higher switch point. So that's pretty straightforward. Then we've got kind of a crossover between one of these latching switches and the tactile switches. So this switch is in the same kind of package as the tactile switch, but it's latching. So when you press it, you can see that it stays down, and you press it again and it pops up again. So this one, you press it, it's on, when you press it again, it goes off. So it latches as soon as it's down and stays on, stays down. Press it again, it unlatches and pops back up again. Right, so those are the basic kinds of switches. Then we've also got a combination of switches. So this is really the same as a tactile switch like this, but it's in a package called a limit switch. And you might have seen things like this on some sliding door security systems. These are used a lot in machinery all over the place. In alarm systems, you'll often find that inside a panel or a box, it'll have one of these, so that if somebody opens the door, it can set an alarm off and say, guys, somebody's opened this door, that's probably bad. So you can see this one just comes with wires to make it easy to plug into a circuit board. This is what we call a limit switch. All right. Again, it's momentary. So if it's pressed, it's on. If it's let go, it's off. The next one is quite interesting, and I'll do a demo on what this is in a moment. This is what we call a reed switch. And a reed switch is a switch that is activated by a magnetic field. So if you put a magnet next to this switch, those little metal contacts inside this glass tube are magnetically charged, so that as it goes into a magnetic field, those close and it conducts electricity. And that's really cool. So it's a mechanical switch that picks up and turns on based on a magnetic field. This is a reed switch, and the reason it's called a reed switch is because those little contacts that sit inside there look very much like little reeds. From there, that's basically most of the kind of switches that you get. The only thing that we can look at after that is this kind of big boxy type of thing. And so all of these switches that we've gone through so far are passive devices, passive electromechanical devices, where you have to switch it physically yourself. This is a relay, or these are relays. And so what this does is it's very similar to these switches that we've got here, but we can control this switch by using a electrical current. So basically we use a small current to turn a large current on. So let's say we could use this to, you can see it says 1 amp at 24 volts DC, but then it says DC 5 volts. So we can use 5 volts to turn on a much larger switch that will carry 1 amp at 24 volts DC. This one is even bigger. This one can handle, it gets turned on by 6 volts DC, and it will switch AC 250 volts at 8 amps. So this one, we can use a small battery powered circuit to turn on, let's say, the lights in your house, or you could even use this to turn on a washing machine or something. Like this can handle a lot of power, can take a lot of current. And basically what we've got is, if we put power between these two pins, then it'll turn these two pins on and it'll turn these two pins off. So it's got multiple contacts on the inside. So that is what we call a relay. Now this is a mechanical relay, or both of these are mechanical relays. You do get solid state relays, which are based on semiconductors, which we will cover in a different video. But that is an overview of some of the different types of switches that you've got. You think I was done talking? No. We're going to have a quick demonstration because I'm a man of my word. So what I've got over here is a little breadboard, and a breadboard is really something that we use to prototype electronics without having to solder bits together again. And remember, before I said that we have this reed switch the one that gets turned on by a magnetic magnetic field. And I said I would show you how it works, and this is how it works. So what I've done is I've built a little circuit over here. Don't worry about these batteries. I've got these batteries connected like this so I can do different experiments with series and parallel circuits. But basically, I've just got one of these batteries connected up to the power rail. So we go see positive wire, red wire going to the positive on the breadboard there. And I've got the negative wire coming out, going to the negative wire on the breadboard there. Then I've got a resistor going from that point, from the positive power rail through to track 10, which is going into the wire of this reed switch. This is quite a big reed switch. Then it's joining to this LED over here. You can't really see the LED that clearly from this angle. You'll see it in a moment. And then it's just going through this brown wire back to negative. And I've taken my little pointy stick and stuck a magnet on it, and let's see what happens. Boom, boom. You can see it's not even touching the reed switch, and it's turning the LED on. It's quite a nice bright blue LED. It's making me a little bit blind every time I do this, but it's so much fun. So that's a reed switch. Where does a reed switch get used most often in our everyday life? It is in one of those door sensor passive things that your alarm system at your house, and you have to close all the doors for you to turn the alarm on, and then you have to run out of the house quickly. I don't know if I'm the only person like that, but all of those little white boxy things on top of your doors, those have a reed switch inside, and then the side of the white box with the door side has a magnet in it, and so when the door is closed, it turns the reed switch on, and your alarm system knows that the door is closed and the alarm can turn on. So that's pretty cool. Right, I'm almost done talking, I promise. But there's one more thing that I need to say, and that is, if we go back to having a look at all of the different switches that we've got here, which ones do we use and under which applications? And this has all got to do with current flow. Remember earlier on we were talking about Ohm's law and how current and resistance and voltage are all linked. And the higher the voltage, the higher the current will be on the same resistance. Now, if we have a look at a switch like this, do you think that this switch would be capable of turning on your washing machine? If you do, you would be thinking wrong. The current that this can take is far, far smaller than the current that a washing machine needs to run. So if you tried to power a washing machine through this little button, it would explode. But if we have a look at this switch, we can see on the side it says that it can take 3 amps at 250 volts AC. That's quite a lot of current, but that's still not enough to turn on a washing machine. A washing machine probably uses around 10 amps at 220 volts. But we've got this big toggle switch over here, and it's difficult to see where you are, but you can see that it says 10 amps, there we go, 10 amps at 250 volts AC. So this switch here is capable of turning on your washing machine safely without exploding. So this type of switch that we use needs to be able to handle the amount of current that flows through it. So these small little switches, these use a tiny current because we're actually using them as input devices and not as power control devices. So these buttons over here, this push button can take a fair bit of current, but generally all we want when we press this button is to be able to tell some system that the button has been pressed. This button is also waterproof, which is incredible. But other switches like this switch would have been probably intended to turn on some sort of light or turn on something that needed current rather than just being used as information. So those are the two main uses for switches that we have. We can use it to turn on power circuits, and we can use them as sensor inputs. And the choice of the switch that we're going to use for that needs to be around what kind of current each switch needs to carry. Is it a small amount of current or is it a large amount of current? I hope that makes sense.